All right, we are going live and very shortly. Waiting for live to appear on Instagram and then we will go live. I hope my audio is clear. Let me just check quickly. Yeah, it seems okay on all streams. Perfect. Well, hello. Today we are working on installing Flux in a smaller GPU. Why smaller GPU? It's because the larger GPU is extremely expensive. So it costs about $1.5 per hour to run on GCP, which is kind of good if you're doing it for research purposes, but not really good when you want to do real artwork with it. So we will definitely aim to run on GPU, which has like less credits, and let's get started on that. And of course, this live stream is a new live stream, so we will be focusing on how to create a Controlnet, how to use Controlnet with Flux. In case if you don't know what Controlnet is, I mean, it is very exciting technology wherein you can actually decide what kind of output you want from image generation model. Once you tell what kind of output you want from the image generation model, and how do you tell that? By generally creating outlines or defining poses or defining depth map. There are few ways to do it, but essentially you can tell, like, in this pose I want this character to generate. So already with our knowledge on LoRa, we can definitely now, once we mix in ControlNet, we will be able to generate realistic characters in the poses that we want, in the setup that we want, in the environment that we want. So that's why this stream is very exciting, and let's get started. So I'm sharing my screen now. Just a second and we will be good. All right, so screens are shared, and now we are in the coding mode. All right, so how do we get started with this? I was working with it a little bit today, so I may have a document that is capturing some of this. So first thing first, how do we run Flux in a smaller model, right? So smaller GPU. So I'm going with L4 because L4 is a smaller GPU, consumes like 3 credits an hour, which is already much less expensive than the expensive one like A100s, which is A100 is like 11 credits per hour, versus what we are using, this L4 is like 3 credit per hour. Still not very good, but we'll see what we can do with it, right? So we'll get started with this. We'll start with diffusers uh, and all this. Like yesterday we discussed that we have to use the newer version of diffusers, which is not released yet, because this ControlNet is not part of the main release yet. Whenever the release happens, I think October this month only the release will come through, then you don't have to perform this step. I personally don't mind doing this, but it's a little bit risky because we are using the software which is not yet released. So that's what is one thing that we'll have to be a little bit careful with. And now we are just going to jump into this thing. If you give me a moment, I want to make some setting changes on YouTube stream. I forgot to do that before we started. So give me a moment and we will be doing that now. Just a second. And then we will discuss how essentially we can use smaller flux models to run on the smaller GPUs. But still it has to be flux 1 dev, because all the loaders that we have trained are for flex 1 dev. So that is something that we have, that's a little bit complexity that we already have, but we will know very soon how to do that. Just a second. I have done it for one video. The second video I'm just updating, and now we are good. All right. Seems to me that we are all ready to jump into the code. All right. So first thing first, this is not what we want to do. This is the from the documentation of using the ControlNet, and I mean, like, there is a lot of YouTube videos which explain what ControlNet is, and probably a little bit later I'll explain. But very quickly I can explain to you what ControlNet is by showing you this image. So if you see this image, which is a pretty recent image, uh, okay. So if you see this image, right, it's defining the outlines of the of a woman, and if you feed this image into a control net model, which is controlling flux, then you can actually make sure that the image that generates follows the same outlines, which is very, very cool. Then you can just take this control net and do a lot of things like style transfers. So you have this image, and then you want to shade it like, say retro style, comics book styles, film styles, and so many other different ways. So definitely that's very, very exciting, but we are not there yet because we have to first run it on L4 GPU. And I think, see, the process to do that is using this floating pointer 8, right? If you see this floating pointer 8 repository, what you see is that they have defined, they have created this smaller, I think it's called, I forgot the name, how to, like, what they called, I think atomized or something, wherein these models are actually cross-compiled into this smaller floating point, because by default it starts with 16 floating point. So with the smaller floating points, we actually consume less GPU VRAM, and if you're consuming less GPU VRAM, that means, that's good, because I mean, like, of course, as part of, there is a trade-off, right? There's always a trade-off. So in this case, the trade-off is that if you're consuming smaller GPU, then uh, your image quality may not be very, very good, but it's fine because we are doing exploratory work, and once we know what works and what doesn't work, we can definitely move to a costlier GPU and use a better a model. But at this moment we are not there yet, so we have to use this one. Now I am finding a little bit difficult to run this because this is essentially just safe tensors. We have a bunch of safe tensors that we are trying to load, and it doesn't work if we just say like how we normally do. So if you go to flux one dev Hugging Face, what you see is like, essentially what you can do is you can just say from pre-trained, and then you have like just specify the name of the model and you're good. But you are not good in this particular case. I don't know how to use this one, because so essentially I did some research before we got before I started the stream. So one of the things that I found out was, you have to give me a moment. Yeah, one of the things that I found out was, when I was doing this stream, you need to have like all these files in place, especially this model index.json. I don't know how it is used, but it says class name, diffuser version, scheduler, flow, Euler, discrete scheduler, test. So basically, what I think is happening here is that it uses this model index.json and initialize almost every part of this pipeline. And since we don't have the luxury of doing that yet, so I need to understand how they are doing it. So we have a flux pipeline. We have this schedulers, text encoders, encoder transformers, clip text model, text encoder 2, transformer, okay, tokenizer 2, transformers, like diffusers. So guys, I have no idea how does it know which of, like, how does it know that it needs to load flux one depth shape tensors. Now that is what we want to learn, how it is doing it. And then, I mean, like, one way of doing that would be to transfer this thing on my local folder somewhere, and then replace this flux one dev safe tensors with latest one, which is I think this 10 days ago, this one. So flux dev floating point 8 em e4 m3 fn safe tensor. Okay, so this is where we are right now. I don't know how to proceed right now, so we have to check. Okay, let me have a look and see what we need to do. Dev.jpg, whatever is this? This is just a picture. And what we see that we have this README, which is essentially the model details, and which is not definitely we know that the model doesn't use this. Maybe one of these things actually use it. Maybe if I go to tokenizer and then we have the vocab.json, maybe not the tokenizer, maybe transformer and config. And what does it do? So name or path checkpoints, flux dev transformer, diffuser version. Okay, so it's not doing too many things here. It's not, see, essentially I just want to know, because I know that we are, like, I know 100% that we have to replace this one, but how, and how to do that would be kind of challenging. Text encoder, this is another model.safetensors.index.json. We know that text encoder will do these things, and it's all model, like, just loading all this. Just text encoder model. Tokenizer we know. Transformer we have seen. VAE, what is VAE? There is another diffusion PyTorch model, and name or path checkpoints flux dev. Okay, why is it using checkpoints? That's another thing that we want to learn. Silos. Okay, so essentially we are getting into now how to initialize these pipelines, and then customize this initialization. Maybe if there is a way to, let's see, what I'm going to do now is, and maybe this will work, maybe this won't. Probably this will work now. I know one way of doing that would be to use Comfy UI, and I'm kind of holding off from, like, using Comfy UI yet, because first of all I have no idea how Comfy UI works, and for my workflow maybe Comfy UI is not like really required at this moment. But if there is enough demand, then I will do that. So first of all, drop me a message anytime, whatever if you have questions or whatever, and I will be more than happy to have a look at that. Meanwhile, let's see. So my goal here now is to use something like this. What I want to do is say content slash model, right? Don't want to do that really, but we have to do it, I feel. And if you see, the biggest part of this model is not, like, if you see this model, right, and file and versions, flux one dev save tensor, that's 28 GB. That's a big one. And if I see it's broken down somewhere, like if I go to transformer, right, see, this is what I was talking about. Like, so basically this is the transformer, that if you can just modify the transformer somehow, then you're good per se, right? Because now you can just load because, see, what I'm saying is that we have this, my feeling, and maybe it's wrong, because I have seen this initialization like hundreds of times, right? Not hundreds of times, but few times. And what every time we see is that, like, see, this is a good example. Whenever we initialize flux one dev model, this is what happens. What happens? It loads different size files, and specifically this one model, whatever this one model 0. This is a tokenizer model. I know because it's not big, but the big model is here, 9 and 3. This is 23 GB model, which is the base model of Flux 1 dev. So we know that the transformers are actually the main model that we want. So my thought process here is that if we can initialize the transformers in a different way, right? I don't know how to initialize this with the save tensor straight away, uh, because if you see, then this is the transform. So my, first of all, to complete the thought, we have this 23 GB of file, which is actually splitted down and kept it here for us to load on runtime. Now, if you see index.json, what do we see? Weight map and all of this, right? Context, bias, weight, no idea. But way too many things, way too many things. I have no idea how to actually do it without having this file. But transformer box, linear dot weight, safe tensors. But essentially it's loading everything via transformer configuration. Now if I go here and I find this one, right, E4, whatever. I feel that this is something to do with this float E4M, which is PyTorch, right? Uh-huh. So this is a different type of float data type and it's compiled that way. Okay. Hmm. Okay, so even this, right, Flux control net is also, this is what I was talking about with control net, right? So you have this, you have human poses, and with human poses, actually you can decide the pose, depth map can decide also this few things. Anyways, we need to break this a bit more and come back to this. How do we use this? This is a Union Pro, so that's good. So this is actually what we want because we don't want to spend like $1, $1.50 per hour to learn things, right? So definitely that there is that, and well, let's have a look at what we want to do with this. So Flux VAE PF 16. Okay, so we have to use one of these state tensors, of course, and this one. If I do that, what do I see? Oh, the download will actually download this file. Yeah, I don't want that. I don't want to download it straight away. A lot of configuration stuff is here, which is weird. I don't know how to load the sentences. Okay, let's see now parameters. We need to break down the parameters. What is the parameters that we want to break down? Sorry if I'm moving this screen too fast. Let me know if it is moving too fast. I can use a normal mouse, but I'm just used to using this, pro mouse, which is fast. So there you go. Flux pipeline, transformers. We want to know what is that we want to send transformers. Conditional transformer, flux transformer, 2D model. All right. Hmm. And I don't know what is flux transformer 2D model, which is defined somewhere, hopefully. Models, transformers. So if I go to models, transformers, and then go to, what is this? Am I transformers 2D? I need to break this down in a different way. No, transformer flux. Okay. Just want to look at the initialization. The number of channels in the input and output, number of attention heads, attention head dim, context free only, fine. So this is how we initialize. No, 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 no. Sorry. This is a different thing. Here it is. Patch size. Patch size to turn the input data into small patches. In size, num layers, attention data head. A bunch of things. Now I don't know how to load these shape tensors in a better way. I think we need like this kind of thing, right? Wherein it needs weight map and stuff. But if that is the case, then they would have also given us, but that's not the case. That's not the case. Shape 128 parameters, whatever. Too many things, but LFS, get LFS and all I know. Fine, I still don't know how to work with this. Okay. Uh, Again, phase, diffusion, pipeline, load, transformer, model, safe, tensors. Okay, load safe tensors. There it is. How safe and fast file formats, storing and loading tensors. Fine. So uncommented install necessary library collab. Now diffusion pipeline. So you can optionally say use safe tensors as true. However, model weights are not necessarily stored in separate subfolders, like in the example below. Sometimes all the weights are stored. Yeah, in this case, the weights are stable diffusion weights, and you can load the file directly from a single file. Oh, that's it. And would it work? Okay, just give me a moment. So what I need to do here? Just need to do this and run. That's all. I mean, come on. If that's the case, nothing better, right? Okay. So at this moment, I don't care about these things yet. So I'm going to comment them out. And we want to also give this correct path, right? If I go to download, maybe it will give me the link, copy link. Will it work? Is the question. What is this? What I just copied the text. Copy link address. Let me download this. Let us see what do we see. The file name. Okay. Copy download link. We give it a shot now. What did you see? Solving. That's weird. But if I go back here, right, what do we see? Oh, yeah, we see like that only. It's weird. Why is this not able to access? Is what my question is. Like, if I copy it here, it shows me the file straight away, ready to download. Why is this model not allowing me to download this single file? FP models often use the float 16 or reduced precision pipeline, whatever from single file. Let me have a look at the documentation quickly again. Okay, if I do like this, right? Wow, there's no stable diffusion. I'm like, I want flux pipeline. Maybe it's doing that something. What is this? Entry not found for URL. That's it. It's exceptionally weird. I'll inspect the URL now. Uh, just a second, guys. Give me a moment. Okay, what do we see? Huggingface.co, warrior mama, whatever. And this works. No, this works. Maybe it's because of git LFS. I don't think so. So I saw one difference, and I don't know if this was something to do with this. So What I difference I saw was if I pasted, yeah, it's working now. Flux pipeline is able to load this model. Hopefully, this model this solves our problem. So it will load it and it will see, right? If I go back to this guy, so what I saw was if I use the my last whatever link I was giving the access to the file versus this link which displays the file in the browser. So I don't know what was the reason, but fine. If it works, it works. I'm not complaining. It just works, right? So what's the point of complaining and getting behind it? All right, another thing, this stream is going to be not a long one actually because I'll have a little bit longer stream coming in second half today, another couple of hours after this stream, and in that actually we'll be using this control net, and hopefully everything works. If it doesn't, we'll continue the streaming till the time everything works as we want it to work. Now, if I go here and look at this, what is this? Image attention. We'll just explain the shape of this thing and bias overlock, whatever. I don't know if this will work straight away. Text in bias weight in there. So this is just the definition of our. I'm so sorry if I'm moving too fast, but I'm just used to using this mouse. It's super fast. So let me know if you want me to slow down the scrolling. I don't know if I can do it with this mouse. I may have to change the mouse, but yeah. Or I just have to be a little bit more mindful. Drop me any comment, anything that you feel like, and I think this we are getting very close to finishing the download. I mean, if this works, I can just keep it in my Google Drive because copying from Google Drive is much faster than downloading from internet. So every time you initialize the model, it just initializes like that compared to all this. Be mindful, right? We are paying for all the time that it spends on downloading. All right, so failed. Why did it fail? Failed to load clip text model. Waits for this component appear to be missing in the checkpoint. Please load the component before passing it as an argument. Before passing it as an argument. So what does it mean? Clip text model from pre-trained. Wow. Okay, maybe we can just use the main clip text model and may work, may not also. We will see. Clip text model. How do we import this? How do we import this? Clip text model. Waits for this component. I know that from the documentation. Clip text model. Where is it? Flux, pipeline flux. Clip text model. Clip tokenizer. Clip text model. Comes from where? Clip text model comes from transformers. Okay. Let's import everything. Don't want to keep going back and forth. Anyways, we are in very like it's a bad practice, of course, in most of the cases. But in this case, it may be fine. So let's copy that model thing from where? Flux one dev here. So we want to use the clip text model from Flux one dev, and let's do that. And then text encoder. I don't know this one. I still don't know. I'm just very early to do this. What happened? Does not appear in the file name config.json. Come on. Check out the flux tag. Yes. There is a text encoder. And if I see it has like this model index.json and clip text model transformer text encoder clip text model to transfer the 5 encoder model, but how do I initialize that now? When this is kind of painful. No idea. There you go. Clip text model, text encoder. Uh, there was an example somewhere, right? If I don't pass, it was giving me that example, but okay. From pre-trained, what are the different things we can pass? We can pass pre-trained model name, optional union, pre-trained config, or cache directory. None, ignore, force download, local files only, token, shift sensors. I have to see some examples how people are doing it, so definitely. You can never do it without guesses, like, clip, clip model from pre-trained. Okay. Clip with whatever. You can do quite a few things, but I just want to know how to clip text model, clip text model. Here it is. Okay, 6 parameters, more attention, mask, position ID, input, whatever. Too many things. Why can't I just use it from here? Black forest left plus one dev. That's exactly what you want. Unless I'm missing something, which in that case I'll just check quickly. This is how we always use, right, from pre-trained. So this might be a painful live stream because we'll be failing so many times. File name config.json remain for available files. Okay. Tree not found for URL config.json. Okay. Pretend without config JSON. Basically, please transformer model without the configuration file. The warning message instead of error doesn't mean it isn't the right one. You can test it on against face, whatever. Okay, still nowhere. That's not even close. Cannot load a pretend compile using ht1. Okay, let's see what people are doing with this. From pre-trained clip v stable AI, stable diffusion base from pre-trained subfolder. Okay, this is what we want. Subfolder clip text model. It expects a clip text model. We give it a clip text model subfolder, and we want to go back to this guy and see what folder we want to access for clip text model. We saw a few things here. If I see the saved tensors, if I see the model index, and what do I see? We see that clip text model goes to text encoder. If I go to text encoder, this is our directory for that, and there is a config.json that might work. So we want to say text encoder folder, text encoder. See if that works. Downloading. Okay, it will now. Fail to load T5 encoder ways in normal component, we're missing the checkpoint, blah 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 blah. Text encoder 2. Okay. Now we want to say what is that? Text encoder 2. Encoder model, and go back to the model, text encoder 2. So this is the folder for that T5 encoder model. T for from pre-trained all of this, and then we can say text encoder 2. I did not pass it, I'm sorry. Text encoder 2 toss type, I don't know what is the type I need to pass. Okay, so this code, as you can imagine, that this code is taken from somewhere, because I've, if you see me, I'd never write comments. So in that case, yeah, I mean, like, this is taken from ChatGPT. So they are telling us to use float 16. We'll start with float 16 out of respect to ChatGPT, and we'll see. Okay, so I may need to drop out in like 10-15 minutes now. And as I said, soon we will be having another stream where we will jump into it more. Okay. Do we see what is happening now? It will fail, of course, for the next model because it expects a lot of model. Shards, whatever. Yeah. So the next one it is expecting is, what is this? Again, text encoder 2. Why is that? Fail to load if encoder. Wait for this model appears to be missing from single file. Text encoder 2. I did. Okay. I know. I put this code after this error happened. So it will fail for more. I feel because this needs a lot of things like clip tokenizer. We need to pass all of this at least, and scheduler. So once we do all of this, it may work. Is it even moving? Crashed. We use so much RAM that session crashed. Weird. We'll try again. Maybe because we are loading the same model over and over, so you never know. We need to clear this out a bit. Like I said, this will be a painful stream because I did not want to go ahead and start using Controlnet and do a direct live stream on that, because then the question would be, how did we get there? So that's why this is the live stream for showing how we can actually run a smaller Flux model on a smaller GPU and then apply whatever text encoding and stuff we want. What happened? I think loading checkpoint starts. Something happens here weirdly. This is where it crashed last time. It's using a lot of system RAM already, 20 GB. Should add prefix to this one. I need to be converted from the slow organizer. Okay, it's kind of stable in terms of RAM stuff, but it's again picking it up. I'm like getting very tempted to just go with a higher GPU because it's just too painful to do. We are still losing a lot of sessions. Like it's going to be crashed. It is going to be crashed. I don't think it's going to even stay. Okay, crashed. Yeah. So we are doing something wrong. I don't know what I'm doing wrong here. To set add prefix space, the tokenizer need to be converted. Prefix state. Let's learn about this. What is this? Okay. Let's have a look. When at this moment I'm getting really tempted to use like Comfy UI. I don't know if Comfy UI can solve this problem, but if it does, that will be the best thing. Oh no, how is it going to use? This is where we are. First of all, I'm going to keep that GPU running for some more time. Where did it go? Here. Where's the Comfy UI stuff? No, it doesn't talk about Comfy UI here yet. I think we are close. Uh, so I'm seeing that a lot of people are telling that make this add prefix space equal to false. So maybe you know on these encoders we need to pass, or maybe the tokenizer. Maybe we need to set up our own tokenizer. Maybe let's do that. So we need few more things in order to get this model running, and one of the things are, if I go back to model index, tokenizer, and we need clip tokenizer. So we'll copy this line and we call it tokenizer, and this will be clip tokenizer from tokenizer. Then we need another one, t5 tokenizer fast, and that is called tokenizer 2. T5 tokenizer first, tokenizer 2. Looks fine. Cool. It's guessed. Uh, okay. Let's try and see if we have any improvement. I don't think we need to install anything. We can just straight away go in because the environment has everything installed, hopefully. Oh, sorry. Maybe it would work, maybe it won't. If it does, fine. Doesn't, we have to probably continue in the next stream because I have to stop stream so very soon. Maybe another 4 minutes, 5 minutes. Let me check when I need to go. I need to go like in 2 minutes maximum. So I'll keep it running and well, I'll keep it running and I'll see you in the next scene. But looks like it's not going to work because putting permanent tokenizer needs to be converted from the slow tokenizer. So it's not going to probably work yet. Okay, I'll see what I can do in the next stream and I'll see you soon. Thank you.